All right, so section 1.1 is what we're going to cover first. Here are the objectives that we're going to talk about in this first section. So we're going to talk about an XY table, a graph, an equation, and how these are defined as functions, what they look like as tables, as graphs, as equations. We're going to talk about domain and range. We're going to talk about a scatter plot, how to put your dots on the graph itself, function notation, and how to this apply to real life, because you know that favorite question that everybody loves to ask, when am I ever going to use this in real life? Well, we get to show you how to do that in this class. So, first topic, what is a function? I'm usually going to kind of mention what's on this screen, and then I'm going to go back and give you some information that makes more sense, or at least it makes more sense to me. So if I read it, it says a function is a rule or correspondence that assigns each element of one set exactly to an element of a second set. Now, does that mean anything to you? No. You just gave me a definition. I still don't know what it means. You still don't know what it means, right? Okay, so let's talk about it in terms that make sense. Me describing what a function is. Do you have a washer or dryer at your house? Yes. Or you know somebody that's got one, or however. This is my dryer. Okay? Y'all like, why is she going to relate this to a function? All right, what goes inside this dryer? In your dryer, what do you put in it? Clothes. What kind of clothes? Wet clothes, okay. Okay, what comes out? Dry clothes. Okay, so now my question is to you, if you put a set of clothes in, do you get exactly a set out? Yeah. Did it say, I have one set of items? You plug it in somewhere, and do I get another set of items out? Yes, you do. So, example, if I put a red wet shirt in the dryer, what do I get out? Red shirt. Do I get a purple shirt? No, I'm going to get a dry red shirt out. So there is a relationship going on. What's the relationship? Is what's happening inside of this dryer. What happens? We don't care what happens as long as you dry my clothes, right? So there's the relationship is the dryer is doing its job inside of here. It's doing something, twirling around, putting some heat in here, but something happens inside of here so that you get something out, what you were expecting to get out, right? Mm-hmm. All righty. So now that we know that, this is considered an example of what I'm calling a function. If I actually change this and say now, I'm going to call this a 1, something's going on inside of here, and I want to get out a 10. What should happen if I put this in? This is my dryer, something's going on in here, but I want to get a 10 out. Could I add 9? What if I put in a 2 and I want to get a 20 out? Could I multiply or add something? Sure. So let's just say we're multiplying by what? 10. That's what's happening inside the dryer. You put one set of things in and you get one set of things out. There's one here and there should be an output. I call this the input. This is called the output. Okay. All right. So I'm just kind of define some of these things here. This side is input. This side is output. You okay so far? Mm-hmm. We're just defining what a function is. You got to put one thing in, you get one thing out. Alrighty? So here, also we call this the domain. What am I going to call it if it's output? Range. The range. What's the variable that we usually use for input and output? Usually they use X and Y. Is that going to be the case every single time? No. They could use C and D, P and Q, X and R. It doesn't matter. Just as long as you know what's happening inside the dryer. Now, what's happening inside the dryer, they're calling a rule or a correspondence. It's some mathematical computation that's taking place. They could be adding, they could be subtracting, they could be multiplying, they could be doing all of the above. They could add, subtract, multiply, and divide all in the same equation. Have you done that before in the same equation? Mm-hmm. Absolutely. So some type of math is happening inside of here, and it's going to spit out a number once we do the calculations. That's what a function is. That's what defining a function. Now, I'm going to give you several different types of how you can view what a function looks like. Right here, this was just defining it for you. So I just defined it for you. So now, we're not going to be able to reach that top board, am I? Okay. I would like to use the top board. Do y'all let me 7 feet tall? I was wanting to use the top board, but I can't reach it for sure. All right, so I'm going to go ahead and use what I have here. All right, so the first example, do you see what it says here? The function can be defined as a set of what? Or. Okay, so I'm going to give you examples of each of those so you can actually see what one is. Can I erase what's on this board? That way I can still use it? Okay, all right, just let me do that. I really want to be able to use the word that moves up. All right, so the first one we're going to do is order pairs. So here we go. 1, 10, 2, 20, 3, 30, 4, 40. Set of order pairs. Now, I just created a function with this set of order pairs. If I put one number in, do I get one number out? Put another number in, do I get another number out? What's the rule of the function? What's happening inside the dryer? Multiplying by 10. So that's the relationship that's happening here. The other reason why we can call this a function, all the x values have to be different. Remember, we're calling this the domain, right? All right, so we remember you got input and output. Quick question. What if I created my order pairs to look like this? Is that a function? Now, here's what you're thinking. Because I thought the same thing when I first learned how to do all of this. Now, you can see the relationship between these numbers, can't you? Yeah. Can you see the relationship between these? I don't know how to plug in 1 and get 2, plug in 2 and get 5, plug in. The same mathematical computation has to happen to create each one of these numbers, just like it had to create those. Here, we could see it easily. It was multiplying by 10. This is where we would put this in Zuru, the little screen I showed you, where you type this in and it will create the relationship for you. It'll tell you maybe we multiply by 2, then divide by 0.2506. You see what I'm saying? So I don't know how to get this, but the computer will generate an equation for us that tells us what math had to be done so that you could get these numbers. I just made this up. This is not, I made these numbers up. You got it? So in order to call this a function, all the x values have to be different. I just don't know how what math got calculated to create these numbers, but that's okay that I don't know that. As long as all the x values are different, I'm good. Is this one also a function? Yes. Can you tell what the relationship is? What do we do? Okay, good. So assuming that you won't always see the relationship immediately because these are too easy, they're not going to make it that easy for you. So you're going to get equations, you're going to get order pairs that look like something like this where you may not necessarily know what math was done to create the second number or your output number. Just know that that's going to pop up that way. All right, so our first type of functions were what? Order pairs. What are we doing next? Okay, table refers to what? X, Y table. Again, do they have to call them X and Y? No. All right, I'm going to use the same numbers we already got. 1, 10. All right? That's just another way of writing a function. That's it. All righty? What about a graph? What's this called? The X what? This line right here. X-axis. What's this one called? Okay. I'm going to graph these points that I already have. I already created them over here. I'm just going to graph them. 1, 2, 3, 4, 10, 20, 30, 40. Alrighty. Now, this is another version of a function. How do I know that this graph is a function? Because in the homework, they're going to give you graphs of functions, and they want you to tell me, is this a function? They're going to ask you this question. Is y a function of x? They're going to ask you that question in the homework. They're just saying, is it a function? Well, is there a relationship? Well, we knew there was a relationship here. There's a relationship here, and a relationship here. I just plotted those same points. Well, we already know there's a relationship. It's times 10, right? How do you do it if you didn't know that there were these numbers? What if I had used these numbers over here? The question is, how can you tell me if a graph is a function or not? It has to pass the vertical line test. So any graph that you're given, in order to tell me that it is a function, meaning y is a function of x, it has to pass the vertical line test. Draw one vertical line, just one. And if it crosses that black line one time or touches it one time, it's a function. If it touches it twice, it's not. So let me give you an example of one that's not. So if the answer to this one is yes, here's my graph. What test am I doing? It's not a function. It didn't pass the vertical line test. It touches that blue curve this many times. It can't touch it but once. To be considered a function, it can only touch the graph one time. So this one, not a function. How would this look if I wrote this in ordered pair form? Okay, let's say call that a 1. This is 2, 4, 6. How would this look if I wrote it as ordered pairs or XY table? So what's this point going to be called? Somebody tell me what the point is. I'm just asking you to tell me what this point is.
1, 0.
Okay, what's the next one?
1, 2.
Tell me, get this one right here.
1, 2.
Okay, you always give me the X value first, then give me the Y. So it goes over 1 and up 2. Okay? This one goes over 1, up 4. This one goes over 1, up 6. Can you see that if you look at it from a graph perspective, yes, you're right, it doesn't pass the vertical line test. But if you take these points and put them in an ordered pair, does it pass?
No.
Why? Because all the X values should be different, and they're not, they're the same. So whenever you get ordered pairs, X values have to all be different. All your input values have to all be different. So if you get a curve that looks like this, it's going to have some similar X values, which causes it not to be a function. Okay? Question. That's for the graph. What's the next type that we're doing? Okay, so we did a table. Here's our graph. Now we're going to do an equation. So for an equation, I'm just going to give you an equation. Y equals x squared plus 2. There's my equation. I want to know if it's a function or not. Two different ways you can do this. Plug numbers in and create an XY table, or you can type it in Desmos and see what the graph looks like. If you type it in Desmos, what's the picture of this graph going to look like? A U. It's a parabola. It's going to look like a U. So here's what that graph should look like. So I'm expecting you to go type that in Desmos, see what the picture looks like. Does it pass the vertical line test? Yes, it does. So is it a function? Yes. All right, and so here's my vertical line. Right. What's the last one we're going to do? A verbal description. You're like, why would I ever need a verbal description to be considered some type of function? Well, here's an example. Here's what you could see on the homework. Your cell phone bill in any given month, X. That's the statement they'll give you. That's a verbal statement. They're gonna say, is that a function? You be like, how in the world that's gonna be a function? That's just an English statement. It don't have nothing to do with math. However, we're gonna turn it into math. All righty, create an XY table. From that statement, we're gonna create an XY table. Well, it will always tell you what the X is, because X is always sitting right next to the word that means X. So in this case, the X or the input value happens to be the month. Okay, so here's my X, and these are the months of the year. So I know what they are, right? Okay, so January, February, March, April, May, June, July, August, September, October, November, December. All right, did I miss one? That should be 12. All right. So, they give you the X. They tell you what X is talking about. The key is now you got to figure out what the Y or the output is going to be called. There was only two topics in this conversation, month and what? Cell phone bill. Okay, all right. Do you get one? Okay, all right. In January, again, we're going to call this Y. They may call it G or Q or P or whatever letter the alphabet they want. So again, did you get one in January? Yes, what might it be? 125, okay. In February, did you get another one? Yes. You did, okay. What was that one? $92? Okay, yours went down. Mine don't usually go down. Okay, what might be another one? Should they usually be similar unless you had some overage charges? Okay, so maybe some overage charges. So again, maybe you dropped somebody from your phone plan, and then you had some overage charges, so it went back up to 125, and maybe it stayed at 125 for a couple of months. And then it was 130 because you added another phone. So again, we got 144, 130, 130, 130, 130. All right. Question. Is this a function? And why do you say yes?
Now, if we're looking at the letters only,
No, you're looking at what they I didn't write them all out. You're looking at what these are. What is this? Don't look at just the letter. Look at what the letter stands for.
okay. I thought you were just looking at those letters then, no?
Okay, no, there you go.
Would they be considered numbers? Like January, first month, February, 2,
Yeah.
and then different, so it's a function.
Okay, so it's a function. So the key here is when you see a verbal statement, you got to create an XY table. And if you can keep all of these different, you're good. It's your function. Because would this ever happen? Well, let me put it right here. Could you ever have February right there twice?
No.
You get two bills in February? I don't want to get the one I get, so I definitely don't want two. So that never happens in real life. You know, when I shouldn't say never, because every now and then something out of the blue had to be like, I don't know why y'all sent me a second. But in most cases, you never have two bills in the same month, right? Okay, so this would definitely be considered a function. You okay with that? This is a verbal statement that we turned into an XY table that we can make into a function. Okay? You're good? You got all the different types of what would represent a function for this first slide. Alrighty, so with that said, let's talk about some real life. When would we use some of this information? Again, we're talking about plugging in and what output that we get out. This is an example of a formula for changing from Celsius to Fahrenheit. In the United States, what do we use for temperature? Fahrenheit. But if you're in other countries, they don't use Fahrenheit, they use Celsius. So in this particular problem, it says the child's normal temperature, suppose the child's normal temperature is 98.6 Fahrenheit, and the only thermometer in the house is a Celsius thermometer. It says that your child's temperature is 37 degrees. Exactly. So does this reading indicate that the child's temperature is normal? Well, if you didn't know, you were like, well, I don't know if the thermometer says it's 37 degrees. So there's a formula, and this is the actual formula for converting from Celsius to Fahrenheit. So if you've checked the thermometer and it says 37 degrees, you can convert it so that you'll know what the actual Fahrenheit temperature is. So in this particular case, guess what they did? What did they plug in? The Celsius temperature, which was?
37.
So they plugged in a 37 for C, and what pops out? Fahrenheit, which is how much?
98.6.
Is that considered a normal temperature?
Yeah, they all right.
They all right. They good. So again, what if the temperature happened to be, let's make up a number. What if it's 41 degrees Celsius? Somebody tell me what the temperature in Fahrenheit is. 41 degrees Celsius. Somebody do it on the calculator. Tell me what the temperature is in Fahrenheit. So you know if your baby got a temperature or not. What is it?
Oh, they said.
Did y'all get that?
They didn't go to the hospital.
Yeah, at this point you're gonna need some Tylenol.
105.
You know, put them in a bucket of ice or something, but you're gonna need something to calm them, to cool them off. So again, you can see the difference in all you had to do was put it into the formula. So it's like into the dryer, what goes in and another number comes out. What math took place?
Multiplication.
We did multiplication, addition, and division, because you got 9/5, which is with 9 divided by 5. So you did different mathematical parts of the equation in your calculator. All right, so you're good?
Wait, hold on.
On the next slide, guys, we're going to give you an example of domain and range. And I need to show you how to write it. Ready? All right. For each of the following graphs of the functions, find the domain and the range. Well, you know what they are, don't you? Now, again, on the homework, they might give you dots on the graph. And they might not give you this table that you see, right? Because they've already done the table for you. But in the homework, can you take those points and create XY table? Yeah, like this point right here, right above me. What's this point right here called?
That's
Negative 4.
negative
Negative
7.
side. Negative 5.
Negative 5, negative what?
7.
So you can see they put it as the first one in the actual XY table? Okay, so they did the same thing with every set of points. So now question, what's the domain? Negative 5, negative 3, negative 1, 0, 3, 5. That's your domain. Done. In the second, the column where it says Y, which is your range, are you going to repeat the numbers that are repeated? No, you do not have to. So what's the range?
Negative 2, negative 2, 5, 6, negative 7.
Okay, so you don't have to repeat the negative 2, and you don't have to repeat negative 7. So when you see it in the homework and they give you a list of numbers like that, don't repeat them, just write them once. All right, questions? All right, this is the same thing for what we just asked. They just gave it to us. So they're saying the range is a set of all the Y values. The X coordinates are the set of all the X values. So they just named them for us. Notice when they ask you for it in the homework, they put them in these braces. See these little curvy things? These are called braces. Usually they'll have them as part of the answer box when you see the answer box, or it'll tell you how it wants to see it as a set notation. This is considered a set of numbers. So when they have these little braces here, it's considered a set. Notice there's a set of numbers for the range, and they wrote them as a set. Notice they also wrote them in in increasing order. So negative 7 is the smallest number. Negative 2 is next. Negative 5. No, they didn't write these in the right order. Okay, so ignore what I just said. They won't matter what order you write your answers in. I usually prefer to do them in increasing order anyway. Alrighty, so there you go with that one. Now, all right, so let's do this. I need you to tell me from the graph the domain and the range. Now, when I say domain, look at the graph and tell me how wide the graph is. You see it's the curvy graph, but I just need to know how wide it is. From this side to this side, how wide is this graph? Where does it start?
-3.
-3. So I'm gonna push this board up so y'all can keep that one. So this graph starts at -3. Where does it finish? On this side.
Negative 3.
Okay, we just asked you how wide it is. So we did that. So again, you now have those numbers. How do you write this in equality notation and interval notation? So I'm gonna do inequality notation first. And then I'm gonna do interval notation second. You have the important numbers. We just need to write them in the proper format. The homework is gonna ask you to write it sometimes in inequality notation, sometimes in interval. If it asks you for inequality, it wants less than and greater than symbols in it. Okay? Inequalities literally means symbols that refer to not equal to. So less than and greater than are not, they're symbols that refer to inequality. And interval notation wants brackets and parentheses. So the first one we're gonna do is the one that's called the inequalities. Always gonna have X in the middle or Y in the middle, whatever variable they're using. We're talking about domain. So it's X. In that case, they use X, so we're gonna use X. And here is what you're always gonna have. Here, this is shorthand. This right here is shorthand for in between. Whenever you see two less than symbols with an X in the middle, it means in between. I want all the numbers in between what? -3 and 3.
Positive 3.
So this is how you will write the inequality for that. You okay? Tell me why there's equal signs underneath those less than symbols. It can be, does it land on the, is the dot, is that a closed dot? And it's up there, is that a closed dot? Yes. So because it's closed, you gotta put equal signs underneath those less than symbols. What if my graph looked like this? All right, so I would need to erase these. You got it? So let me put this back and put this over here. So this would be less than, that's what that one would be. You okay? All right, what if I did this?
And one would.
Okay, so this one's gonna have an equal sign and this one's not. Not. All right? All right, you good? How do you know which one gets the equal sign? So if looking at the graph, there's a left side and a right side of the graph. So because this is on the left side of the graph, I'm gonna put it here on the left side of that X. Over here, this is on the right side of the X, so I'm gonna put it on the right side. Right side of the graph, I meant. Say it again. How did you know where to put the equal sign? This is the left side of the graph, so I'm gonna put it on the left side of the X. This open circle is on the right side of the graph, so I'm gonna leave it off on the right side of the X. Was that clear? Okay, every single time you see the words or you see something that's in between, you would always use less than symbols. You never, ever can put two greater than symbols there. If you see it, it has to be twirled around because your final answer has to, if it's two numbers and it's in between, they have to end up being less than symbols. Have to. Alrighty, so this was inequality notation for all three of these. Now let's do interval notation. Interval notation uses brackets for closed dots and parentheses for open dots. So, what did we have on the slide at the beginning? Closed or open?
Closed.
Both of them are closed. Do we already have the two numbers that we were looking at? Yeah. Done. This says I want all the numbers, or X is all the numbers in between -3 and 3, including -3 and 3. So we included the -3 and 3. How would I write it over here for this one? And what about here? Let me put this back. This
One bracket on the left and parentheses.
right. We're good? Now, this was just for the what? Domain or range? Which one? This was just for the domain. All right? So for the range, can we do something similar? I need you to look this way. This way. Not this way. Look this way. How tall is this graph? Yes.
40.
I have a question.
Yes.
The bracket is for if it's less than, and the parentheses are if it's equal to?
No, the bracket is if it's a closed dot.
Oh, so, okay.
Close is bracket, open is parentheses. See, this got an open circle up here? That was it. All right, so back to this way. Where's the bottom, the last point on that curve? Okay, it looks like it's close to -30, but they're using -27. You see, it's not quite at 30.
Oh, okay.
So it's saying the bottom of that is at -27. So I've got my number here. Where's the top of it approximately?
39.
They're saying 39. So I got my two numbers. Now, again, because they're closed dots,
Greater than equal to line.
now, are we saying all the numbers in between? Yes. As long as you say all the numbers in between, we're looking at the graph for everything in between, we got to use two less than symbols. This will always be less than symbols when it's going to be all the stuff in between there. All right, so there's my inequality notation for range. We're talking about range now. And this is the inequality notation. All righty, what about, how do I write this in interval notation? Brackets? Okay. Comma and a closed bracket.
Okay, so if you use a different number like 25, then it wouldn't be like, you wouldn't use a less than sign?
When you say 25, tell me where you want to put that.
Negative 25.
If I use -25 instead of -27,
It's already in there.
but it's already included in the, if it was already included in the
So
graph
if you use -30 though, then it would be
outside,
open.
correct? Because
No,
-30,
I'm saying for the,
which one?
inequality notation.
For the what?
Inequality notation.
Yeah, but for, we talking range or domain? Which one? You doing range? So if this was 30, 30 is not a part of the graph. It's not on there at all. So we can't include 30. So if we put this and make this a -30, you can't include 30. You see 30 is not, we didn't even reach -30. Can you see that this graph doesn't reach negative, it doesn't even come down?
But if you did like negative 25, it would be a greater than?
Never gonna be greater than.
It's always gonna be.
If I'm talking about, I wanna see all of the graph that's in between here and here, whatever number is here at the bottom, and whatever number is at the top, you're still always gonna use two less than symbols. Always. And the key is that whenever you're using two less than symbols, the smallest number should always be on the left, and the larger number should always be on the right. Always. Now, you're like, well, what if somebody actually have it written and it looks like this? Could I actually see it written like this? Well, let's see. How about if I put 5 is greater than or equal to x greater than or equal to 1? Could I see something like that? You could see it, but that's not typical of how we want to see it. Now, let me ask you a question. Do you ever say, I want all the numbers between 5 and 1? You see what I'm saying? It doesn't even sound right to even say it the way. So what has to happen if you ever saw it written like this? This is not the format that my math lab is going to want it. It wants it with the less than symbol. So how do we correct this? Twirl the whole problem around. Literally twirl it. When I say twirl it, I mean turn it around. So what happens if I twirl this problem around? 1 goes here. The symbols become less than, and the 5 go over here. Your smallest number should always be first. So if you see it written with 2 greater than symbols, you got to twirl the whole thing around. The smallest number always has to be first. All right, you okay? All righty. All right, what about this one? Now this graph looks a little different. This graph looks a little bit different because why?
Going to infinity.
It's going to infinity. It doesn't have 2 ends that stop like the previous graph. So now we got to figure out how to write interval notation for graphs that don't stop. Okay? So What are we gonna do first? Domain, this way. Look at the graph this way. All right? It's starting someplace and continuing that direction. Where does it start? Look,
Negative or 4.
it starts at 4. Okay, so let's erase this so I can use this part of the board. So it starts at what? 4. And goes which way? Negative infinity. So I'm writing the interval notation first, because you said it goes that way. Now, do I need brackets, parentheses, or one of each? One of each. So we included the 4. We always close off an infinity symbol with a parentheses. This says I want all the numbers 4 and anything less than 4. That graph is it includes all the numbers for 4 and anything less than 4. Well, how do I write that? This is domain again, guys. We're talking domain. I'm just looking at the x values. So what are all the x values that I want? If I want to write inequalities, that means I need less than or greater than symbols. I want all the numbers what? That less than 4. How do I write all the numbers less than 4? Less than or equal to 4.
3, 2, 1.
You keep going. 3, 2, 1, 0, negative 1, negative 2. Now we did forget some numbers that I didn't say. What about negative 1.549?
Yeah.
There's a whole bunch of numbers after negative 4, but positive 4. Just so you know, this includes decimals, fractions, all kinds of numbers less than 4. So this is what notation is this one? What notation is this when you write brackets and parentheses? Interval notation. What's when you have less than symbols? Inequalities if you have less than or greater than symbols. Okay, you okay? This was just for the domain. All right, what about the range for this graph? Which way am I looking to get range? Where's the bottom of the graph at? Look at the y-axis. Where's it at the bottom? Look at the y-axis. 0. Let me make it bigger for a second so I can. So we're just looking at the bottom of the graph. Where's the bottom of it at? On the y-axis. 0. All right, so the bottom is going from 0, and where is the top of the arrow going to ever end up? All right, now you want to say what? I heard 2, then I heard 4, then I heard infinity. Which one is it? Infinity. That arrow tells me this graph is never going to stop. So is that arrow going to keep on going past the ceiling?
Yeah.
Absolutely. So here, for interval notation, I end up with 0 to positive infinity. All right. So how do I write this in inequality notation? I want all the numbers bigger than or equal to 0. So we're talking range, so I want everything greater than or equal to 0. All right, what are you thinking? You okay? Okay, so far so good. You're not ready to drop, right? Okay, I just want to make sure y'all not trying to drop my class. All righty. Real world, real life. Let's talk about it now. All right, so for the following, determine whether or not the indicated relationship represents a function. I just want to know if this is a function. Explain your reason, indicate domain and range. All right. There will always be a topic of conversation, and you need to make sure when you start doing word problems, because y'all know this is a word problem class, right? Okay, you need to make sure you understand the conversation that we're talking about. What the topic is, does it make sense about what we're talking about? So it says the PC industry celebrated its 35th anniversary in 2010. The United States sales S, that's the what? That's your Y, that's your output. They did not call it Y, they call it the sales S of these personal computers in the millions of dollars by year X. So now they did use the X value variable, are shown in the table on the next slide. So is S a function of X?
Yes.
All right. Well, you can look at the table and your answer was? Are all the X values different? Yes, they are. So the answer is yes. All right. What's the domain?
1975, 2015.
All the way from 1975 to 2015. What's the range?
0.04 to 122.
Okay, so And what else did they say about the cells? So you trying to tell me they had 0.04 cells? That's it? They ain't selling not one computer?
In millions of them.
In millions of computers. So that's 0.04 million cells. The next one is 0.76 million cells. 6.6 million cells. So you're saying those in the millions of cells that they did. We okay? Okay. Just making sure, because sometimes they'll have those numbers there and you're thinking that's the actual number and it's actually in millions. All righty. Does the equation define y as a function of x? What are you supposed to do when they give you an equation you want to know if it's a function?
Put it in decimals.
Put it in decimals and see if it
Pass the vertical line.
see if it passes the vertical line test. Go. Go to decimals. If you have your laptop, go to decimals. Type it in for me, please. Were y'all able to type it in okay? You were able to type it in okay? What kind of shape did you get? The picture, the graph, what shape does it look like? A sideways U? Yep. That's what you would have gotten, a sideways U. So when you look at it, it should look like that. Does it pass the vertical line test? It does not. No, it doesn't. What about the next one? Type the next one in. Upside down U, thank you. The next one should look like that. Does it pass? Yes, it does. Questions? Okay, so just remember, this one does not pass, and this one passes. Yes?
Is there like a certain reason why, if we were just looking at the equation, could we tell like would it be a function just by looking at it if we didn't put it in decimal?
I know because I know what that graph is going to look like. The question is, can you look at an equation and tell what it's going to look like just by looking at the equation?
The y squared says.
Y squared always going to look like a sideways U. Yeah, x squared is always going to look like a parabola. So yeah, if you know what that shape of that graph is going to look like, then you can answer the question. So
Squared is always a function.
y squared, always, you see y squared and x is not squared, always going to look like a sideways U. Alrighty, so you have different shapes that are going to look like different things. Some graphs you're going to get, they're going to look like this. So again, some of them you won't know that until you actually put it in a graphing tool so you can see what the graph is going to look like. Alrighty, next one. So here is what we just said. We just did the vertical line test for both the upside down U, which is a parabola, and the sideways U. All right, next part of the conversation that's on our objective that we want to make sure we cover today was function notation. So you learned some different notations. You did inequality notation and interval notation. Now we want to talk about what does it mean when something is written in function notation. And here's what it looks like. F of x. That's how you read this. Don't say F parentheses, X parentheses. It's F of x. Why do we have it written like this? Because at least when it's written in this form, I can tell you what number to plug in for x. X is always your domain in this case, right? So if I want to tell you to plug in a 4, can you just put a 4 right there?
Yes.
Yes. If I want you to plug in a 5, can you just plug in a 5? Yes. So one of the ways to actually look at this and see what you're supposed to do is if they give you a value of x, you're literally just plugging that number in. To what? What are you going to plug it into? The equation that they give you. What is that part? Here's what you see up here. You got 2x to the third plus 5x squared minus 28x plus 15. This is what's going on inside your dryer. They're doing a whole lot of math. So again, something's being raised to the third power squared minus, you're doing all the math here. So everywhere there is an x, you're going to put the number 4. Do the math in your calculator. So It may say find, like you see in part B, it says find, or part A, it says find f of -2 and find f of 4. It literally means plug in -2 and plug in the 4. So if you do this math on the calculator, here's what you're going to get. Did you all try it? You've got to make sure your calculator works like you know it needs to work. And how many of you actually already have a calculator, or you already bought your calculator? You're still working on getting it?
Do we need a different one?
No. As long as your calculator has this button, you're good. LOG for log. If you have that on your calculator, it'll have everything else you need. Okay, so you're looking for that button. Preferably, your calculator should be where you could see what you type on the screen. You know, sometimes if you type 2 + 3 and hit enter and it just puts the number and deletes everything else, you would like to be able to see it, and when you hit enter, it leaves what you typed on the screen. That's preferred, because that way you know if you made a mistake. You'll be like, oh man, I forgot to put my minus sign. So that way you'll see what it typed. That's just my preferred, but if you already have one and it does what you know it needs to do, that's perfectly fine. Did you get this? And for calculators on, you will definitely be able to use your handheld calculator for every test. The only thing is that you won't be able to use your computer calculator. You will not have access to your computer calculator, and it says you can only use your handheld calculator. All righty, questions?
Where do all these numbers come from?
Which ones?
Cause you adding in the negative for that.
Which one? Are you doing?
Substituting it
Yeah, but which part are you at?
at F,
The top one on
the top one B, the top one on B.
The top one on B? Wait, like right? Are you plugging in -2 or 4? Which one?
-2.
-2. So when you plugged in -2, okay, so look up here. Now, do you have to do please excuse my dear Aunt Sally if you're going to do this by hand?
No.
What? If you're going to do this by hand, you're supposed to be, you got some parentheses, you got some exponents, some multiply, division, and add and subtract. So yes, if you're doing this by hand, you got to see that you follow that rule. Your calculator should, I'll say should, know to do this automatically. It's like it's got a built-in, please excuse my dear Aunt Sally. So it should know how to do, if you type it in right, let me preface that by saying, if you type it in right, your calculator should give you the right answer. And it's a good idea for you to check and make sure if you type yours in that you're going to get that answer. So, did you get what you needed on yours? Did it come up?
Oh, I don't know.
Okay, gotcha. All righty, questions? This is plug and play, y'all. Now, if you don't get this part right on your calculator, it means you didn't type something in right. That's all. All righty, so... All right, back to real life again. All right, we're talking about domain, range, input, output, and how do we see it in real life? It's graphed on a graph. We talked about graphs. So let's see what the conversation is. Elderly men in the workforce. All right, the points on the graph give the number of elderly men in the workforce in the millions as a function of, G of what? Your T. What letters of the alphabet did they use for variables? G and T. Which one is output and which one is input?
G is no, G is Y.
G is the output and T is your input. So let me give you a hint here. Usually T will always be time. Seconds, minutes, hours, days, years. T will usually be time. So time is usually always your input. So T is input, G is output. So we're looking at years and how many elderly men were in the workforce given a particular year. So if I look at what year? If I look at 1950, how many elderly men were in the workforce?
45.8 million.
45.8 million men were in the workforce. What happened in 1960? It's declined down to 33.1. And then what in 1970? What happened? Could they have retired? Okay, but I'm saying could they have retired, or it could have, a lot of things could have happened. we bottomed out at what year is that?
80, they was on that crack and stuff.
1990. What happened in 1990s? Now, I'm not a social studies or history buff, so I cannot tell y'all what happened during these periods of time to know what happened during this time. So, just know that if you do some research, you might find this information accurate. Now, look at it. It picked back up after what? After the 1990s, it started to pick back up. And we did a prediction for 2020, 2030.
The Social Security running out, so that's why they. I'm serious.
And like I said, this is a prediction, guys. This is just a prediction.
Oh, they gotta go back to work.
So now again, this is for elderly men. Now we're not talking about the young folks. We're talking about elderly people. You know, if you
do at Walmart and stuff.
all right, so you know, hopefully I'm not expecting to have to do that when I turn 80 and 90. So, but anyway, can you understand what the graph depicts? You see what it does. You got a year, how many men were working? Another year, how many men were working?
Million was working in 1950. Look at that.
That's a whole lot.
Yeah, and then look how much it dropped. Cause they out here robbing and stealing and hustling.
I don't think the elderly men are robbing and stealing.
Okay, I forgot. You got some old ones out there doing this stuff.
Okay. All righty. So next, we want to make sure we answer the question, answer the statement, find and interpret G of 2020. When they say interpret, it literally wants you to give me an English statement, words, explain to me in words what G of 2020 means. Give me a verbal statement. In what?
In 2020,
There.
21 million men will be, elderly men will be in the workforce.
Yeah. In 2020, there are 21 million elderly men in the workforce. That's just what they want you to say. The homework will do the same thing. It'll give you 4 different answers. Which one is the right answer that says what they just said on the screen? So you pick the right one that says that, makes that statement. All righty. Next one, let's see. We're talking about the same graph. The same graph. What's the question? What is the input T if the output, which is G of T, is equal to 19.16? Now the question is, do you understand the question? It said, what's the input? Meaning what year
2030.
was there 19.6 million men in the elderly men in the workforce? 2030, done. You just look at the graph. There's nothing else for you to do but look at the graph. They gave you the Y value or the G value, and they wanted you to find the T value just by looking at the graph. All right, same graph. What can be said about the number of elderly men in the workforce from 2020 to 2040? It's decreasing. So maybe all the young people started to take up the slack for their grandparents. Is that what happened? Just joking. Don't know what's going to happen in 2020. So we got over 20 years to think about, or that's declining. All righty. Now, same thing. What's the maximum number of elderly men in the workforce during the period that's shown on the graph?
1950.
The maximum number of elderly men in the workforce? 45.8 million. Yeah, that's the highest number that we've seen so far from this graph. All right. The last couple of slides for this section. Public health care expenditures. What is that?
The money they spend to keep it afloat.
So, do you have health care?
Yes.
Yes, most of us do, whether it comes through our job or whether we're on, public health, whatever it is that we still got some health care. So, how much money is being spent on health care? All right, so it says public health care expenditures for the period of 1990 to 2012 can be modeled by, and that is accurately approximate by the function, and they give you the function E of T. Why did they choose the letter E? Expenditures. Usually when they start using different variables, they'll pick a letter or a variable that refers to the conversation that we're having. So we're just saying expenditures of a period of time, which T happens to be the number of. What's T? Look at what it says. What is T? Read all of that part. T is what? The number of years after 1990. So you got to decide how many years that is, because that's what T is going to be. It's not going to be 1990. It'll be how many years after 1990 will be your T value. Now, E of T is the billions of dollars that we spent. So if they say E of, and they want to say, and let's look at the actual question. What is the value of T that represents 2010? So, okay, so how did you get 20?
Go all the way from 1990 to
Okay, so you counted from 1990 to 2010, or you just subtracted the 2 and got 20. So T is 20. So since T is the number of years after 1990, T is 20. So that represents 2010. How would I determine how much money that was that we spent on health care? Plug it in. Where you gonna plug 20 at? Where T is, and then what? Put in your calculator, see what it is. All right, go. Those of you got your calculator, put that T in, put 20 in. Tell me how much money we spent on health care. And what year is this? 2010. While y'all doing that, did everybody sign the sign-in sheet? Where is the sign-in sheet? Will you pass it over to me, please? If you haven't signed it, please make sure you sign the sign-in sheet. You have to sign the sign-in sheet every day you come in here. All right, what answer did y'all get? There we go. And this is in what? Billions of dollars that we spend in 2010 on health care. Okay? And then the next question asks, what about 2015? How much money did we spend in 2015? If you use your calculator, you'll see it's going to be $3,563.3 billion on health care in 2015. Y'all got to stay healthy. Okay, all right, question. All right, that's the end of section 1.1. Usually, guys, what I will usually do, this class ends at 5:50, right? Because it's at least 2 hours for this class, we're supposed to give you 2 10-minute breaks. So I usually just stop class earlier than to give you 2 10-minute breaks. So that means we'll finish this right around pretty close to 5:30. So if that works for everybody, we'll get out of here right at around 5:30. So I'm going to go ahead and start talking about what you'll see in the homework, and then I will actually go on to section 1.2 just to give you a brief intro to 1.2. So let me pull up my math lab. You know, you might not be able to get to it yet, but I need you to see it. So I want you to feel comfortable with the homework when you get to it. So I'm just going to pull up 1.1 and give you an idea of what the homework looks like. So when you get to it, you won't be like, oh my God. All right, so let's look at the first one just to give you an idea. What you'll see, and does it make sense? I want you to be able to look at the homework and see if it makes sense to you. So they're asking you, does the table describe X as a function of Y? What's different about that statement than what we've been doing on the board, or what's kind of mixed up? Something's not wrong. I won't say something's wrong with it, but something's not right with it the way we did it. What's different with the question? They switched the Y and the X around. So they want you to look at that differently. So they're asking you, does the table describe X as a function of Y, when we're used to doing it the other way around? So we're used to looking and seeing if all the X values are different. Now, because of the way they wrote it, we want to know what? If all the Y values are different. That's why I'm saying they may use different letters of the alphabet. Just make sure you know what's input and output. So anytime you see that statement where the X is, what's in front of this as, where you see the described as, that's always output. Whatever letter that is. You got what I'm saying? This letter or variable is always input. Whatever letter they choose to use. So you're always going to be looking to see if these numbers for that column are all the same, or are they all different. The trick with this one was they switched the X and Y around, and when we've been doing the different examples on the board, we always put it with Y in the front. So just notice, whatever's the very last letter you see is what you're looking to see if they're all different. You got what I just said? That last letter variable that you see, look in that column and see if they all different. They are, it's a function. So what's your answer?
No,
DC.
It's not.
Are all the y values different?
no, they not all different. It's two
So
ones.
wouldn't it be?
So now, is the y considered an output or input column?
That's put in the
Input.
The y's right now, they are the input column. So we're calling this y value an input, so now we're gonna say no, but which one of the no values is right?
D.
Because we're calling y the input column now, so we gotta call it y, the input y value. So it's gotta be D. Now, do you see what I mean when I say sometimes it's how it gets to be read? I wouldn't trick y'all on a test like that. I wouldn't just trick you. I would just be, straightforward with you. But again, just now that you know what to expect. All right, so now the answer for this one, if you check it, we'll check it and just make sure. The input value that got doubled was 1, so they're expecting you to put a 1 there. So yours should be the same as mine. We check it, it says we did a good job. So again, you can go on and look at the next question. Let me shrink my screen. I'm showing you these because sometimes it's how you read the question that makes you understand it better, making sure you understand what you see. So now in this one, part A says find f of 0. What is it asking you to do?
Plug it in, plug them numbers in.
All right, so what you gonna plug it into? This is part A now. You're only looking at the table. You're not looking at B or C. Look at the table. It says, what's f of 0? Well, what's 0? 0 input? Is that an input number?
Yeah.
Yeah. So if that's the input, what's the output for 0? 4. Thank you. They just want you to look at the table and what's the input value, what's the matching or corresponding output that goes with it. That's it. Okay, you see why I can say this is how you see it. And all of the homework, not all, a lot of the homework when they write their tables like that, they make them horizontal tables. I like my XY tables to be vertical, but most of them, when they write them like that, they're horizontal. So if you put in 0, you get out of 4. We okay? Not part B. So again, if I put a 4 here, I should be okay. Now it'll go on and let me do the next part. Now it's asking you to do the same thing. This time, what do they want you to do with the 0? Plug it where? In the X in the equation. So everywhere there's an X, you're going to put a 0. So you got to do 10 minus 2 times 0 squared. All right, what's the answer? Okay, y'all were quick with that one. All right, so I'm going to put my 10 in here. Now the last one could be tricky, depends on how you see it. They want to know what's f of 0. All right, tell me what the input value was. What was the x value that we plug it in? 0. Find 0 on the x-axis first. Where's 0 on the x-axis? It's right here. Now come down or up wherever you got to go to hit that curve. Which way you got to go to hit the curve? Down. How many? 2. So if you plug in a 0, what you going to get out? -2. Done. We're good? Okay. So I'm just giving you guys, I'm saying I want to make sure that when you see the homework, it doesn't look like it's a foreign language to you. All righty? We're good? Okay. All righty. Let me go to, hold on, shrink my screen back down. All right. I'm just scanning through. Okay. It doesn't matter if I answer them because this is just mine. All right. You got the same question. It says use the graph to evaluate f of -1. Look at the graph. What's f of -1? Find -1 on the x-axis. Find -1 because the graph, it says find f of -1. Find the x-axis and find -1 on the x-axis. Okay, you got to go up or down till you hit the red line. Which way you going to go? 1, 2, 3, 4. We're good? All right. This one wants you to do what? Okay. So what are we replacing? What variable? R. Everywhere you see an R, put a 7. Do the math. Okay. So y'all see how easy this is?
That's just for right now.
We're going to keep it positive.
That was fine.
Yep, we gonna keep it positive. All right, the domain and range. You know how to do that, right? Okay, so now first of all it says, does the table define y as a function of x? What column or row, not column, what row are we gonna look at to see if they're all different? The x row. Are they all different? Yes. So it's a function. So now it says if it is a function, tell me what the domain and range are. So you're gonna literally just type it in between the braces that you see here. Questions? Questions? All righty. Going on to the next one just to see what we're looking like. All right, determine if the graph to the right is y. Is it a function?
Yes.
Y. Passes the vertical line test. All right, which of the following order pairs defines a function? Let's see, we want to know which of these is a function.
A and B.
Are they both or just one? Okay, so you're telling me that part B is not a function because you have double fours right here? All the x values have to be different. So you're right. So A is a function, B is not. Alrighty, what about this one? So here's how you have to see this one. So the x's are different, but now look at if you write it a certain way. So for the first one, 13 and 15 go together, 4 and 17 go together, and 7 and 15 go together. All right, this a function? Yes. All right, what about the next one? 3 goes with 1, and then
25 and 13.
25.
And then 25 and 19.
So B is not a function.
That's not.
So B is not a function. So you see how that works? Okay, this is called the arrow diagram. Just make sure you put the numbers that go together so you can see that it's in their duplicate. Alrighty, find the domain and range. What you gonna do? You're gonna create order pairs from all the points and find out what all the x values are and all the y values. Alrighty, now this one, again, if you know what that equation is and you know what this shape is gonna look like, you'll know how to answer without graphing it. So if you know what that is, you can tell me right now, is this a function? Yes, it is a function, or no, it's not? Yes, it is. Do you know what the shape is?
It's gonna be like that or something?
Well, let's look in.
A squared is going forward.
Okay, well, let's put it in and see what it's gonna look like. Where is my decimal set? What was the equation again?
X squared plus Y squared.
Equals what?
81.
81. All righty, let's do it. All right, y raised to the 2 power equals 81.
Circle.
No, it's not.
Anytime x and y are both squared, it's going to look some type of circle. So, does it pass the vertical line test? No, it does not. So that's why I said you can definitely use decimals, because if you know what the shape is going to look like, you'll immediately know whether it's a function or not. Okay? Questions? All right, let me see where I was. Let's see. Homework. All right, so we did that one, and let's look and see what the rest of them look like. All righty, this is an interesting one. Okay, so they're talking about, during the first 2 weeks in May, a man weighs himself daily and records the data in a table. You know, we've done that before, right? Be like, look, I'm trying to lose some weight. Let me put this in this table, see how much pounds I lost. All right. Does the table define weight as a function of a day in May? So now question. What's the X and what's the Y? What's input, what's output? The days is what? X. And the weight is your Y. Okay, so is it a function based upon knowing that? How do you know?
Because the days would be different.
They're all different days. From 1 to what? 14 days. Alrighty, I like that. In the next few questions, it's going to ask you how many days was he at his highest weight. Let me look and see what the next one says. Continue, hold on. All right, it's asking you for the domain. We know what the domain is, right? What's the domain?
1 through 14.
1 through 14, so you know how to answer that question. All right, it says we did a good job. All right, if we continue, it's gonna ask you a different question. Now it says, what's the range? We already know what the range is.
178 to 175.
Okay. All right, I'm waiting for that. There's one other question I wanted you to see.
81 pounds, my bad.
Okay, during what days did he weigh the most?
4,
What days did he weigh the most? Well, what's the highest weight that he got up to?
81.
Okay, so 181. On what day was that?
The 4.
Okay, so then you would end up putting in 4 because that's the day that he weighed the most. And then there's another question. So this is day 4. And I think this is the last question. What days did he weigh the least?
The 12, wait a minute.
What was his lowest weight?
The
So
7
do you
was
do
158.
8 and 10?
So the 14th and the 12th.
So the 12th and the 14th, he's 175. So we will put 12, 14. Notice it says use commas to separate your answers. Make sure you read what's in the blue because it'll definitely give you information on how they expect you to write your answer. So again, that's just to give you an idea of what to do with that. Let me see if there's anything. Oh, there is one other question here. He claimed to be on a diet. What is the longest period of time during which his weight decreased? Okay, so look at it here. Okay, so did he increase? Yeah, did he increase? Did he increase? Ah, wait, he went down.
Went down.
All right, so starting from here, I think we count from 5. So he went down, starting from 5, he went down, down,
Down.
down.
Then back up.
Okay, so what day? From day 5 to day 8?
8, yeah.
What's the longest? So that's 5, 6, 7, 8. Is that 4 days? All right, let's see. Let's see if it likes that answer. Hey, it likes that answer. We good? All right, so y'all got a chance to see what the homework should look like. We won't start 1.2 because I'm not going to be able to talk about it a lot. What questions do you have for me before I dismiss you guys?
I got a question.
Yes.
I just want to make sure, you said that if it gives us a question that says, describe, whatever letter percent as a function.
Yes.
So whatever letter they use before as is the output or input.
Yeah, the first letter you see will always be output, and the last letter you see will always be input.
Okay, and then it's always input and y always output.
If they give you those 2 letters. If they don't give you X and Y, you got to figure it out. Because they could have gave you C and D, P and Q, X and R, but the way it's written, look at the way it's written. Like I said, the last letter, if it's a question, the last letter is always input, no matter what letter of the alphabet it is. All right, what other questions do you have for me? I will send you out an email if I figure something else different about this My Math Lab thing. Even if I have to call Pearson and see if there's something we needed to do differently. I do have a question. In your little packet thing, does it say do anything special underneath your code? Like who has this thing? Let me see yours for a second. Hold on, let me see if I put in Pearson. I want to see if it comes up with a different screen. Make sure you sign in before you leave. Yes, ma'am.
ISBN number, for the book, because when I look up the 4th edition, it's showing the old cover.
Either one will work. If you get the 5th or 4th edition, they ain't changed but a couple of words in the book, and the book is the
I just
same.
wanted to make sure.
Yeah, either
But
one.
As long as I'm using the, course code, I'm good.
Yeah.
No matter what. Okay, because, Chad has the cheap.
Yeah, the old book works just as good as the new book.
I just wanted to make sure.
Nah, they're the same.
I was going by the description.
No, you're good.
Okay.
Desmos, DESMOS.com. And you need to make it a favorite. DESMOS.com, click start graphing,
And we
and
need our handheld.
your handheld calculator, absolutely, absolutely. Did they give it?
Yeah, I got it, but I don't think you like something email with the
You didn't get it? What's your name again?
Kendall Brown. Oh, the second page.
I did call you? Okay. Last name again?
Brown.
Brown. Okay, so when did you just sign up for the class today?
Sign up for it.
Then you should have been on my email list then. And it's coming to your Clayton State email now. That's your Clayton, is that the email you're looking at? There's only
I
going,
just checked though.
no, but you just checked your Clayton State email? Okay, cause I sent it out at like 8:30 this morning. If not, send me an email, just send the email back from the, can you send me an email and see if I got yours?
9 days left. And he was giving me a hard
Yes,
time.
ma'am. Okay. So you guys just look for an email from me about getting access, cause I gotta figure that part out.
Okay, I have a question.
Yes, ma'am.
Thursday, you said I have to miss, and I have to leave no later than 5 o'clock.
Okay.
My son graduates from high school.
Oh, of course you can't miss that, and I wouldn't miss it
I
either.
gotta go all the way to the Georgia World Congress Center.
Okay.
Will I be able to, once I miss, I'm lost.
Okay.